So this video is just going to focus on the combined gas law. And so you'll notice that the problems that I left for you guys to do are the same problems that are on this sheet because I was able to leave an answer key for you then, not for you to get the right answer, but for you to be able to see if you're going about this correctly. And so you want to make sure that you're working on the process, and that's why I'm not going to grade this, but you want to have this ready for you Wednesday so that you're going to be able to make sure that you're doing the stuff correctly, especially on the test on Friday. So question 2, a toy balloon has an internal pressure of 1.05 atm and a volume of 5 liters. If the temperature where the balloon is released is 20 degrees Celsius, what will happen to the volume when the balloon rises to an altitude where the pressure is 0.65 atm and the temperature is negative 15 degrees Celsius? Okay, here's the first thing that we need to talk about. You need temperature in Kelvin every time that you're going to do these gas laws. Okay, it's got to be over in Kelvin. And so make sure when you're doing Charles's, or if you're doing Gay-Lussac's, where you're having to deal with that temperature, that it has to go to Kelvin. And so the combined gas law is going to be the same way. So what I did is I took this information from problem 2 and I went ahead and put it on a slide over here. So I knew what our initial pressure was, our initial volume, and our initial temp was 20 degrees Celsius, so I'm adding 273 to get to the 293 Kelvin. The pressure that we're saying that the balloon rises to is 0.65 atm, and we're saying the temperature is going to be negative 15 degrees Celsius, so add that to 273 and you get 258 Kelvin, and we're trying to find what the volume of that balloon is going to be. So this is a combined gas law. So I've set everything up here. This is what I have set up, and I'm trying to solve for V2. Okay, this is algebra, guys. You're just trying to get, V alone, and how do I solve for that? So down here, I showed you how I did it. If we're trying to get V alone, let's think about what we need to do. T2, if it's being divided, needs to be multiplied over to get rid of it. So I'm going to multiply it over, so I end up with P1, V1, T2. Okay, that leaves me P2, V2. If I want V2 alone, I still got to get rid of this P2. So currently he's being multiplied. I'm going to have to divide him to make him go away, okay, to cancel him out. So then over here I get T1, P2. So here's my setup, and here's, how I went about doing this. Now you just manipulate and put your numbers in. So like I said, we had these guys multiplied together. We're bringing 258 Kelvin over. So we did that. We're trying to get V2 alone, so we're dividing the 0.65 A2, okay? Or sorry, 0.65. All right, so I'm going to just bring the calculator up over here maybe. And let's do this. So I have 1.05 atm times 5 liters times 258 equals, all right, and I'm going to divide what's on the bottom. So left parenthesis, 293 times 0.65 right parenthesis equals. All right, so I've got 7.11, yeah. So 7.11 or 7.1 by the time you do sig figs of liters left, all right, is what we're expecting to happen to our balloon. That as it rises up, if the temperature's dropping, the pressure's going down, we're expecting the volume to go up on that with the change in the pressure. Okay, so, and that's why our balloons pop when they go up in the air, because as the pressure's going down, the volume's going up. Label wise, how do I know I got to liters? I want to just talk about this quickly. This is why Mr. Young and I are crazy about you guys doing all your labels, because then you know exactly where you're going. So notice ATM over ATM. Kelvin is on bottom and Kelvin's on top. You're left with liter. That's your only possible option for a label. Okay. Like I said, work through these problems, guys, to know how to do them. You're going to have to know how to do them without an answer key on Friday. And actually, these come back up later in the year when we do what's called stoichiometry. Something else comes in called the ideal gas law, and these guys make a reappearance. So like I said, learn it to learn it. Don't worry about just getting to the right answer. Worry about what's the process and does that make sense between the relationship. Today you guys are going to work through these gas laws, these gas law problems, and then I hope to be back on Wednesday. If I'm not, I'll have some videos explaining the labs and all that kind of stuff and see how we're doing preparing for Friday. If you guys have questions, please shoot me a message, send me an email, and I'll try to help the best that I can. All right, thanks.